Hello everyone. In this video, I will explain about joint probability distribution, marginal distributions, independent variables, covariance of x and y, and correlation of x and y. First, let us see that what is joint probability distributions. In the previous chapter, we have discussed probability distribution which is associated with single random variables, whereas joint probability distribution is connected with two random variables. That is, a distribution associated with two random variables is known as joint distributions. Now we'll define what is joint distributions. If x and y are two discrete random variables, as I said that it is defined for two random variables. So here x and y I takes two random variables, capital X and capital Y are two discrete random variables. We define the joint probability function of x and y by P represent probability. P of capital X is equal to x, capital Y is equal to y is equal to f of xy, where f of xy satisfies the conditions. Two conditions it satisfies. One is f of xy is greater than or equal to 0 and sum of f of xy is equal to 1. That is, sum for all the values of x and sum for all the values of y, f of xy is equal to 1. These are the two conditions must satisfy in the joint probability distribution. Now, let us take x takes the values x1, x2, so on, xm, small x1, x2, so on, xm, and y takes the value y1, y2, so on, yn. Then, p of x is equal to xi, y is equal to yi, is equal to f of xi, yi, and that is equal to j, I, j. We write it as f of xi, comma yj is equal to j, I, j, where j, I, j denoted as joint probability function of x and y. For I is equal to 1 to m and j is equal to 1 to n this is called joint probability distribution of x and y. Now we'll see that the joint probability table. So let us prepare a joint probability table. So in the table, here I take x values. All the column wise values we take x1, x2, x3, so on, xm. And y value we take it as a row wise, y1, y2, y3, so on, yn. Now we can fill this element, the center part of the table. This element we have to fill. So here the first value, this represent j11, j12, first row, j13, and so on, j1n. That is, x1, y1 is j11, x1, y2 is j12, x1, y3 is j13, and so on, x1, y1 is j1n. Now, for the second row, this is a matrix representation itself, j21, j22, j23, j2n. And for the third row, j31, j32, j33, and so on, j3n. And continuing so on, we get mth row. Continuing so on, we get mth row, that is jm1, jm2, jm3, and so on, jmn. So here, this elements in the joint distribution. So this element, this is important when we solve the problem. How this represent? So x2 y1. This represent j21, x2, y2 represent j22, x2, y3 represent j23, and so on. x2, yn represent j2n. Similarly, in the third row, if I want to show, x3, y1 is j31, x3, y2 is j32, x3, y3 is j33, and so on. x3, yn is j3n. Continuing so on. For the mth row, xm, y1 is jm1, xm, y2 is jm2, and so on. xm, yn is jmn. So this is completion of joint distribution table. Now here I take a total. Here you can see this is total and this is total. Now this sum we can get, how this sum or this total we can obtain by adding row wise. So this total or this sum we can obtain by adding row wise. This sum we can obtain by adding column wise. Now if you add all the element in the first row, that is j11, j11 plus j12 plus j13 and so on, j1n is equal to f of x1. Adding second row, j21 plus j22 plus j23 and so on, j2n is equal to f of x2. And adding third row in the element, j31 plus j32 plus j33 and so on, j3n is equal to f of x3. So this is how we calculate f of x1, f of x2, f of x3 and so on. To get f of xm, we have to add mth row jm1 plus jm2 plus jm3 and so on, jmn. So we obtain this f of x1, f of x2, so on, f of xm. Now come to g of value, g of yj, or g of, we'll start with g of y1. This represent y1 column. So here to obtain g of y1, we add j11 plus j22 plus j31 and so on, jm1, we get g of y1. Now come to the second column, adding all the element in the second column, that is j12 plus j22 plus j32 so on, jm2 is equal to g of y2. Now come to the third column, adding all the elements in the third column, j13 plus j23 plus j33 and so on, jm3 is equal to g of y3, and continuing so on. For the nth column, we can add all the element in the nth column, that is j1n plus j2n plus j3n so on, jmn is equal to g of yn. And this distribution, we say that this is f of x1, f of x2, f of x3 so on, f of xm. This represent in the margin of the joint distribution, and g of y1, g of y2 so on, g of yn is also in the margin of the joint distribution, and therefore this is called marginal distribution. It is there in the next slide. I'll be explaining it. And sum of all this value, x distribution value, this is called x distribution, marginal distribution, and this is called y marginal distribution, and sum of all these values you have to get a 1. So that is, I've written here f of x1, the same thing what I've explained, so that f represented here. F of x1 we can obtain by adding all the elements in the first row, that is j11 plus j12 plus j1n. F of x2 we can obtain from adding all the elements in the second row, j21 plus j22 plus j2n, and continuing so on, f of xm is equal to this. And g of y1 we can obtain by adding all the column elements, first column j11 plus j21 so on, jm1. G of y2 is equal to j12 plus j22 plus so on, jm2, and continuing so on. G of yn is equal to j1n plus j2n so on, jmn. Okay. So this is what I said, f of x1, we can obtain f of x1, f of x2 so on, f of xm, g of y1, g of y2 so on, g of yn, by adding all the entries in the first row, second row till mth row, and adding all the entries in the first column, second column, and nth column, that will be representing by f of x1, f of x2, so on, f of xm, and g of y1, g of y2, so on, g of yn respectively. And this is called marginal distribution of x and y. So what is marginal distribution of x and y? F of x1, f of x2, f of x is on, f of xm are called marginal distribution of x, and g of y1, g of y2, g of y3, so on, g of yn are called marginal probability distribution of y. And to obtain f of x marginal distribution of x, we have to add all the entries in the first row, second row, and continuing so on. All the entries in the first column, second column, and continuing so on, we obtain marginal distribution of y. Also, it should be noted that f of x1 plus f of x2 plus f of x3 so on, f of xm is equal to 1. Already I explained in the joint distribution table itself. And g of y1 plus g of y2 plus g of y3 so on, g of yn is equal to 1. And this is equivalently we can write as summation of I is equal to 1 to m, summation j is equal to 1 to n, f of xi yj. So that is x takes the value from 1 to m, y takes the value from 1 to n, f of xi yj is equal to, this is nothing but jij, joint distribution. I is equal to 1 to m, j is equal to 1 to n, jij, that is equal to 1. So which means, it means that total of all the entries in the joint distribution, joint probability table is equal to 1. Now let us move on to the independent random variables. So this question will be asked in the problem. What is independent random variables? In the discrete random variable x and y are said to be independent random variables if probability of, or p of capital X is equal to x, capital Y is equal to y is equal to p of x is equal to x into p of y is equal to y, which implies, and this is true for all the value of x is equal to xi and y is equal to yj, and which implies f of xi into g of yj is equal to jij. This is already, we know that we are representing it in terms of f of x comma y, and here p of x is equal to xi, that is nothing but f of xi, p of y is equal to yj, this is nothing but g of yj, and that is equal to jij. The meaning is, in the joint probability table, the product of its marginal entries, this is product of its marginal entries. Marginal entries is f of x1, f of x2, so on, f of xm, and in the bottom of the marginal entries, g of y1, g of y2, so on, g of ym. So therefore, the product of its marginal entries is equal to jij, then x and y are called independent. Otherwise, x and y are said to be dependent. So this is about independent random variables. So to check the given distribution is independent random variables, we have to check that whether the product of marginal distribution is equal to joint distribution. That is, when you multiply f of x1 and g of, when if I take I is equal to 1, when you multiply f of x1, if you want I'll show it by writing. So if I give I is equal to 1, so that will become f of x1 into g of j is equal to 1 I'll give. So that is g of y1. So when I multiply f of x1 into g of y1, you have to get j1, 1. That is the first entry in the joint probability table. Okay, is that clear? Now we'll move to the next concept, that is about expectation, variance, covariance, and correlation. Expectation for the random variable x and y. For x distribution, expectation of x is equal to summation xi into f of xi for I is equal to 1 to m. This is the formula to find the mean of x distribution. And for y distribution, expectation of y is equal to summation yj into g of yj, where j is equal to 1 to n. This is a formula we need to remember to find the expectation of e of x and expectation of y distribution, and it is denoted by mu x and mu y. Now variance. To find variance for x distribution, we use this formula e of x square minus e of x whole square. So this formula also we can use, or this formula we are familiar in the previous chapter, that is in the binomial distribution, finding the variance. Whereas here we will use e of x square minus e of x whole square, because this is nothing but expectation of x we can obtain here, and e of x square we can find by using the other formula. And variance for y distribution is e of y square minus e of y whole square. E of y, that is nothing but expectation of y, that is whole square. E of x square and e of y square we have to find. Next, standard deviation. So what is standard deviation? That is nothing but square root of variance. So standard deviation for x distribution is a square root of variance for x distribution. Standard deviation for y distribution is square root of variance of y distribution. Now let us move on to the covariance. This is important. If x and y are random variables having mean mu x and mu y, then covariance of x and y is denoted by C co xy is equal to, this is a formula, e of xy minus e of x into e of y, where e of xy can be found by using the formula summation I summation j xi yj jij. So that is summation I, x takes the value I is equal to 1 to m, y takes the value j is equal to 1 to n, and into jij. This is how finding e of xy minus mu x into mu y. This is expectation of x into expectation of y. The correlation of x and y is denoted by rho of xy, that is covariance of x comma y, divided by standard deviation for x distribution into standard deviation for y distribution. So these are the formulas, mainly expectation of x and y, then standard deviation, covariance, variance, standard deviation, covariance, and correlation. We have to remember the formula. Now we'll explain with example. Let us move on to example. The first problem: the joint probability distribution of random variable x and y is given by, now the distribution is given. So this already I mentioned that this value is x value. This represent x value. This is what our x1, and this is x2. And this row wise, this value represent, this is what our y1, this is y2, and this is y3. Now this is J11. This represent the first element in the joint probability table, J11. This is J12. This is J13. Similarly, in the second value, J21, J22, J23. It is asked to find the marginal distribution of x and y, covariance of x and y, and correlation of x and y. First, we'll find the marginal distribution of x. So, how to find the marginal distribution of x? In the joint probability table, we have to add. So, I will add one more table here to elaborate the example. So here, if I add 1 by 8 plus 1 by 4 plus 1 by 8, we get f of x1. 1 by 4 plus 1 by 8 plus 1 by 8, f of f of x2. So on adding this is 1, and here it is 2. 1 plus 2 plus 3, and it is 4 divided by 8. F of x1 is 4 by 8, whereas here 2 plus 1, 3 plus 1, this is 4 by 8, that is f of x2. So this we can put in the table. X takes the value 1 and 5, and f of xy we can find by adding the first row of the joint probability table, and in the second row adding all the element we get this. Now marginal distribution of y we can get by adding first column elements of first column. Next, this value we can obtain by adding all the elements in the second column. This we can obtain by adding all the elements in the third column, that is 1 by 8 plus 1 by 4 we get g of y1. 1 by 4 plus 1 by 8 we get g of y2. 1 by 8 plus 1 by 8 we get g of y3, that is 1 by 4, 3 by 8, 3 by 8, 1 by 4. So this is about finding marginal distribution of x and y. Now let us move on to expectation of x. This is what our formula, xi into f of xi, where I takes the value 1 and 2, and when you expand the summation we get x1 f of x1 plus x2 f of x2. What is x1? X1 and x2 are 1 and 5, and f of x1 we can refer the previous table. This is f of x1, this is f of x2, and substituting here we get e of x is equal to 3. Now move on to expectation of y, that is expectation of y distribution. Formula is summation I takes the value 1 to 3 yi into g of yi. On expanding the formula, y1 g of y1 plus y2 g of y2 plus y3 g of y3. Substituting the value from the previous table, this is y1, y2, y3, and this is g of y1, g of y2, g of y3. Adding this value, substituting, we get e of y is equal to 1. Next, we'll move on to expectation of xy. To find expectation of xy, this is what our formula says. Sum of x takes the value 1 to 2, j takes the value, y takes the value 1 to 3, xi yj into jij. On expanding this summation, we can write when I is equal to 1, j is equal to 1, x1 y1 into j11 plus x1 I is equal to 1, j is equal to 2, that is x1 y2 j12, x1 y3 j13, x2 y1 j21, x2 y2 j22, x2 y3 j33. So if it is finding difficult to remember the form, this expansion, if it is not possible, it is enough if you remember this formula, and we can refer the joint distribution table. According to joint distribution table, that will be easy to find out what is e of xy. So I'll try to draw here. So here this values are x values. So what is our x value? 1 and x values are 1 and 2. Okay. And here this represent y values. What are the y values? Y values are, we start with the -4, I think -4. Next y values are 1 into 2. So 2, and the third y value is 5. Correct? Y3. No, it is a 7, I think. So y values -4 to 7. Let me check in the here. -4, -4, 2 and 7. These are y values, and x values are 1 and this is 1 and 5. Okay. Now this is x1, this is y1. So this into this and into this is j11 value. So that is already given 1 by 8. So you have to take 1 into 4 into j11. That is what here it is written, 1 into minus 4 into 1 by 8, plus 1 into 2 into j12, that is 1 into 2 into 1 by 4, plus 1 into 7 plus j13, that is 1 by 8, 1 into 7 into 1 by 8, plus now move to the second value of Ex. So second value is 5. 5 into minus 4 into j11, j21, that is 5 into minus 4 into 1 by 4, plus 5 into 2 into j22, that is 1 by 8, plus 5 into 7 into j23, that is 1 by 8. So from the distribution table itself we can obtain what is E of xy. It is easy to find out. So use these tricks to find the expectation of E of xy, that is equal to 3 by 2. Now let me move to the covariance of x and y. According to the formula, expectation of xy minus expectation of x into expectation of y. What is expectation of xy? We already obtained from the previous, that is 3 by 2. What is expectation of ax? That is nothing but mean of mu x into mu of y. Substituting the values, we get minus 3 by 2. Further, we find correlation of x and y. The formula is rho of xy is equal to covariance of xy divided by standard deviation for x into standard deviation for y. Now we have sigma x square is equal to, that is variance of x. We have to use the formula to find variance of x. Then we can take the square root of variance is nothing but standard deviation for x. Now variance for x distribution is E of x square minus E of x square, x whole square. E of x already we have calculated, the value is 3, that is 3 whole square. Whereas E of x square we have to find. To find E of x square, our formula is summation of xi square into f of xi. So that means I'll explain here. So this is our x distribution. So in the x distribution, here x takes the value 1 and 5. Okay, x takes the value 1 and I'll write here 1 and 5. So this is our f of x1. And f of x1 already we got f of x1. This is 1 by 2 and this is 1 by 2. This is a marginal distribution for x. Now first you have to take xi square, that is 1 square into 1 by 2. That is what I've written here, plus 5 square into 1 by 2. That is what I've written here. This is how finding E of x square. Minus 3 square already we got expectation of x. Substituting this, we get sigma x square is 4. Therefore sigma x is square root of variance, that is 2. Similarly we can find for y distribution, standard variance for y distribution formula represents E of y square minus E of y whole square. E of y whole square is nothing but expectation of y represent mu y. It is already got, the value is 1. Now we have to find E of y square using the same y distribution we have to use. So here this is represent y and this is represent g of y1, and we have to take y values, that is minus 4 and 2 and 7, and corresponding g of y value we can obtain from marginal distribution of y. To find E of y square, squaring this minus 4 square into first value of g of y1 plus 2 square into g of y2 plus 7 square into g of y3, that is minus 4 square into 3 by 8 plus 2 square into 3 by 8 plus 7 square into 1 by 4. On simplification we get 79 by 4 minus 1 is the expectation of y, which is already we got as 1. So that is equal to 75 by 4. Therefore standard deviation for y distribution is square root of 75 by 4, that is nothing but 4.33. Therefore correlation of xy is equal to covariance of xy divided by Standard deviation of x into standard deviation of y, substituting all the values which we got in the previous, minus 3 by 2 divided by 2 into 4.33, that is equal to minus 0.1732. So this is about solving the problems on joint distribution, marginal distribution, expectation of x and y, covariance of x y, correlation of x y.